Hello, today we're looking at higher order derivatives. So what's a higher order derivative? Let's scroll over to the side. Let's take a look. Let's pick a different color. Let's try gray. Okay. So we've seen, we're back to purple again. That's okay. So we've seen, so for a given function f at x, we've seen f prime. That's when we take the derivative once. So next we're going to look at f double prime. So this is when you take the derivative twice. So differentiate twice. Let's make that it. Differentiate 2 times. When there's 1 prime, differentiate once. One time. And so on. So if we have f to the n, this means differentiate n times. So after a certain point, it becomes a bit silly writing all the primes. Like if you have 10, if n was 10, you have 10 primes there, kind of hard to keep track. So at this, when the number gets large enough, we just put it in brackets. Okay, so given that, let's see what we're asked to do today. So we're asked to find y double prime. So we read it like that. If you have 2 primes, then we say y double prime, where y equals 3x cubed plus 2x squared minus 4x. So let's do this. So we need to start with the first one, y prime. Okay, so what do we have? We have 9x squared plus 4x minus 4. That's our first derivative. Second derivative is the derivative of y prime. So now we're going to look at this function, 9x squared plus 4x minus 4, and take the derivative of that. And what do we get? We get 18x plus 4. So this is our second derivative. Let's see what we have next. Okay, so we're asked to find f triple prime. So 3 lines there, where our function f at x is x minus 2 over x 4 minus 3x. Okay, this one will require a bit more work. Let's start with f prime. So we need to use quotient rule. So 1 times 4 minus 3x minus negative 3 times x minus 2 over 4 minus 3x. And what do we end up with? 4 minus 3x plus 9, sorry, not 9, 3x, my mistake, plus 3x minus 6 over, 4 minus 3x all squared. And this equals, let's try and clean up the top. Oh, that's interesting. Does that work out? That works out nicely. So that 3 x's cancel out, and we're left with negative 2 in the numerator. Okay, so let's rewrite the first derivative as negative 2 times 4 minus 3x raised to the negative 2. Now let's just check this. I'm always very suspicious when things work out in my favor. All right, so we're going to use the quotient rule. The derivative of x minus 2 is 1 times our denominator, 4 minus 3x, minus the derivative of the denominator, which is negative 3 times the numerator, x minus 2, over 4 minus 3x all squared. Let's simplify the numerator. So we have 4 minus 3x, and we have negative times negative 3, positive 3 times x, 3x, negative times negative 3, is 3 times negative 2, which is negative 6. Looks like it works out. Wow. Happy birthday to me. Okay, so now f double prime, we're going to take the derivative of the first derivative. Okay. So writing it in this way, where we have our function in the numerator, makes it a lot easier to take the derivative. So now we have 4 times 4 minus 3x to the negative 3 times negative 3. We can simplify that, and we end up with negative 12 times 4 minus 3x raised to the power negative 3. Now, the third derivative just the derivative of this, negative 12 times 4 minus 3x raised to the power negative 3. So we have negative 12 times negative 3 times 4 minus 3x raised to the negative 4 times negative 3. Let's simplify all this. We got 3 negatives. That's a negative. We got 12 times 3 times 3. So that's 12 times 9. That's 108, I believe. Times 4 minus 3x, all raised to the power negative 4. That wasn't actually so bad. That's good. Okay, so let's see what we have next. That looks like double prime. So find f double prime for f at x equals 2 times the square root of x squared minus 3x. Okay, let's give this a try. Again, start with the first derivative. Okay, so 2. Okay, so what I like to do when I have a square root is I like to rewrite the function as x squared minus 3x raised to the power of 1/2. It's just easier to visualize. So with that, we now have 2 times 1/2 times x squared minus 3x raised to the power negative 1/2. Our 2's cancel out. Actually, I think we have space. And we have, let's see, x squared minus 3x raised to the power negative 1/2. All right, so now f double prime is just the derivative of this. Oh, it looks like I forgot something. Oh, it's always good to check your work. Okay, so see what I forgot? Forgot to use the chain rule. So I took the derivative of square root, but I forgot to take the derivative of what's inside the square root. So derivative of x squared minus 3x. So what's under the square root? That derivative is 2x minus 3. Okay, so let's simplify that again. Our 2's cancel out. And we have x squared minus 3x raised to the power negative 1/2 times 2x minus 3. Okay, that looks good. Now let's take the second derivative. Okay, we're going to use the product rule. Let's take the derivative of the first factor, so negative 1/2 times x squared minus 3x raised to the negative 3 over 2 times 2x minus 3, all times 2x minus 3 again, plus derivative of the second factor, which is 2 times the first, which is x squared minus 3x raised to the power negative 1/2. We can simplify things, but the more work you do, the more chances of error you have. So if you don't have to simplify, then I would just leave it there. Okay, last one, I believe. Find y triple prime, where y equals 6x to the power 4 minus the square root of 3x. Okay, so again, we always start with y prime. Y prime is 24x cubed minus 1/2 times 3x raised to the negative 1/2 times 3. Let's clean that up a little bit. And, yeah. Okay. All right, so now let's do y double prime. So we need to take the derivative of this. So derivative of 24x cubed. So what do we have? Let's see, 24 times 3. We have 72x squared minus derivative of this second term. So 3 over 2 times negative 1 over 2 times 3x raised to the negative 3 over 2 times 3. Good, that looks good. Now let's simplify a little bit. 72x squared. We got a couple of negatives here. That gives us positive. So we have a 3 and a 3. That's a 9. Then we have a 4 and a 4. Sorry, a 2 and a 2, which is 4. And times 3x raised to the negative 3 over 2. Okay, we're getting there. Finally, y triple prime. Okay, so 72 times 2 is 144x minus 9 over 4 times negative 3 over 2 times 3x raised to the power of 5 over 2 times 3. Let's simplify a little bit. And again, you can stop here unless you're asked to simplify. We have two negatives. Oh, that should be a positive, my mistake. So we have a positive and negative, so we end up with a negative. Let's see, we have a 9 times a 3 times a 3, that's 81 over 4 times a 2, which is 8 times 3x raised to the power of negative 5 over 2. Good, that's our y triple prime. That brings us to the end of our video today. So thank you for watching. If you have any questions, send us a note to info@raisebymarks.com or give us a call day or evening, and we'll be happy to answer your questions. See you soon.